When a fault occurs on a transmission line somewhere on the line, currents are flowing to ground. Measuring the direction of the flow of the ground current is used to assist some of the pilot-aided distance protection schemes in determining if the fault and the source of the ground current are located on their transmission lines. The ground directional overcurrent elements let the pilot-aided schemes know if the ground current rises above a minimum set level, and if it does, what direction the ground current is flowing. The ground directional overcurrent elements are used by the pilot-aided schemes because they are sometimes more sensitive to detecting faults than the distance elements are when the source has a weak in-feed or high system impedance ratio. The benefits of using ground directional functions in pilot schemes are that the zero sequence and negative sequence currents that are used to detect the direction of ground currents do not contain very many load components. Therefore, the pickup levels for the ground directional elements can be set very low and thus are very sensitive. The ground directional elements are also very fast operating because the zero sequence and negative sequence currents build up from practically a zero pre-fault value. Also, since there was no ground current before the fault, the pre-fault zero sequence and negative sequence currents do not bias the direction of the developing fault components.